The aim of statistics is to provide insight by means of numbers. Statistics tries to answer the question, what is the data telling us, in an objective, scientific manner? Data and numbers are most likely to yield their insights to those who examine them closely. Learning to think critically about the data before believing it is the goal of every statistics student, and it is the goal of this lesson. We will read several examples and discuss some good questions to ask, hopefully to get some insight and some practice in this important skill. Let's take a look at example number 1. In 1994, according to the Department of Labor, the median salary for government workers was $29,528, while the median salary for private workers was $26,494. Conservative groups have claimed that this shows that government workers are an overpaid, privileged class. Does this make sense to you? Well, I don't know about you, but it doesn't make sense to me. That's not what I've come to believe talking to some of my friends who work for the government and from what I've been told by other sources. So a good question to ask whenever something doesn't make sense is, what didn't they tell us? Are they leaving something important out here? Well, if we were to ask that question, we might get a little more of the whole story, which goes something like this. The nature of salaried jobs in the government and the nature of salaried jobs in the public and private sectors is so different that a comparison of median salaries can be misleading. I'll explain what I mean by this. For example, government doctors and lawyers receive salaries. Most private sector doctors and lawyers are self-employed, so their income doesn't go to the Department of Labor's calculations, even though they often earn much more than government employees. Let's take a look at example 2. ARM, allergy relief medicine, switched to a new maximum strength formula. But the old formula had 37.5 milligrams of active ingredient, while the new formula had only 25 milligrams. So Consumer Reports in April 1985 queried the manufacturer. What didn't they tell us? Well, Consumer Reports found out that the FDA limited the maximum dosage of the active ingredient. And so the company complied with this new limitation by lowering its dosage, and since it was the new maximum, they called the new tablet maximum strength because it contained the federal maximum dosage. Perhaps it's very creative advertising, but it's still misleading. Let's move on to example 3. In example 3, we're going to read about 2 papers. Two papers were written on similar topics, and it turned out that identical data points appeared in each of the 2 papers, but the actual number of subjects cited was different for each paper. Do you have any questions as to whether or not these are legitimate results? When we've got regularity of data between the 2 papers, but inconsistency in the number of subjects, of course we're going to think something fishy is going on. It could be that the data was falsified, made up, or changed. Or or it could be that it was reported inaccurately. In either case, the numbers aren't to be believed, and more investigation is warranted. Example 4 is about a student project. Back in June of 1999, a group of students did a project on M&M peanut candies. And they said in their report that they took a sample of 1,000 M&M peanut candies, and they investigated it to determine the proportion of each color that was produced, and here are their results. They claimed that 20% were brown, 20% were yellow, 20% were red, 20% were blue, 10% were orange, and 10% were green. Well, you might be wondering, what in the world is the problem here? Well, as I read that, and a lot of my students do projects on M&M candies, plain, peanut, dark chocolate, all the different kinds that they have now. And the M&M company, Mars, the M&M manufacturer, Mars company, publishes all of the proportions for their candies. And it just so happens that these proportions are the exact population proportions that Mars claims to use for the peanut candies. Now, you've been a student long enough to know that this is a huge red flag. What did we learn when we were doing the Reese's Pieces a few lessons ago? Every time we did a sample, we got something different. So to have a sample of 1,000 M&M peanut candies give us every single exact population proportion is impossible. And so, of course, when I talked to these students, they admitted what had happened, and were kind of caught because the numbers were just too good. Let's look at example 5. The article in the Durham Morning Herald, February 23, 1982, entitled "Most People Surveyed Like Chapel Hill Parks," reports that 3/4 of Chapel Hill residents are satisfied with the town's parks and recreation programs, according to a survey conducted by the Chapel Hill Parks and Recreation Commission. Of 258 persons who answered the survey on Chapel Hill Parks, 96% were white. 38% of the 10 non-white surveyed said they were satisfied with recreation services. 73% indicated they use the parks. Seems like a very believable study here, but let's take a closer look at these percentages. 38% of 10 non-white surveyed said they were satisfied with the recreation and park services, and 73% of them said that they use the parks. Well, what is 38% of 10? Well, we know that we need to take 38% as a decimal and multiply that by 10 to answer the question. So 3.8 people said that they approve. Now, how could that happen? I can see 3 people, I can see 4 people, but I don't understand 3.8 people. The same holds true with 73% of 10. If we do the multiplication, 0.73 times 10, we get 7.3 people. Again, another impossibility. So always check percentages. Many times they're blatantly inconsistent, as they are in this particular example. Moving on to example 6. An Associated Press article in the Lafayette Journal and Courier, June 12, 2000, entitled "TWA Thinks Positively as Industry Consolidates Without It," states that Southwest does, however, carry a far greater number of passengers, 65,288 in 1999, to TWA's 25,790. Do these values seem believable? Well, at first blush, there's probably nothing that calls your attention to maybe something that is inconsistent here. But a little bit of digging gives us some pretty interesting information. In the 2000 statistical abstract, it was stated that 600 million people flew in the U.S. alone in 1997. And this was a time when airline industry was really growing, so there were probably even a lot more than that in 1999. And we have only 65,288 on Southwest for the entire year, and 25,790 on TWA for the year. I don't think so. I think the author meant, in fact I know the author meant, to say that 65,288,000 flew on Southwest, and 25,790,000 flew on TWA. These numbers are obviously inconsistent. Moving on to example 7. An article in Forbes magazine, April 8, 1996, said that the computer maker Packard Bell had sales of $20 billion over 10 years and $45 million in profits, a profit margin of 2% of sales. Does this percentage seem right to you? Well, let's check the arithmetic. How do we find a percentage? If you remember, percentages come from fractions. We divide the part by the whole. So in this particular instance, our part would be the 45 million, and the whole that we're comparing it to would be the 20 billion. So when we do that, we actually get 0.00225, or 0.225%. The article stated that the percentage was about 10 times greater than it truly was. So it's always a good thing to double check percentages.